If you're new to Blender or intermediate and you're still struggling with the concept of subdivision modeling versus Boolean n-gon modeling, this video is going to be fantastic for you. I will show you what's the difference between these two and what are the use cases for both of them and how to understand each of them and when to use it, okay? So let's grab a cube and we're gonna duplicate it, so Shift D. I'm gonna be working with add-ons like Hardobs and Box Cutter and Machine Tools, but don't worry about it because what I want you to focus on is not what I'm actually pressing, but what's happening on the screen and what I'm actually explaining, okay? So these two cubes are identical, right? And this cube, we're going to simply run a bevel on like this, and we're gonna run a cutter with Box Cutter, right? And we're gonna apply weighted normal modifier, which is going to flex all these faces and flex the shading. So we have flat faces, relatively small bevel here, and we're good to go, right? Now this cube, what I would like to do is also run a Boolean on it, right? And I also would like to run a subdivision on it, so Control 2, and you see, that's what's gonna happen. So why this is happening, right? The way the topology is being handled and also the way that all these highlights and bevels are being applied to each of these is completely different, okay? If I'm going to Shift this cube and I'm going to apply a modifier to it, so I'm going to use the uniquify and move it in here, so it's the same cube, and I'm going to apply all these bevels and cuts, to this mesh. So this is going to be a real mesh. You'll see how it works, okay? Bevel is holding all these edges and it's actually applied only to these edges around the cube. And then these faces are being flattened by the modifier, which is called weighted normal modifier. If this modifier wasn't applied, you see we're going to have a problem with shading. Do you see what I mean? So this modifier flexes the faces, right? The bevel creates a highlight, and the smooth by angle here is averaging the smoothness between the bevel and the flat faces, right? So these two modifiers are actually essential for for shading, properly shading this cube. Now subdivision modeling is completely different, okay? All these edges here that define this bevel would need to be created manually, and they're called edge loops. You're using edge loops to kind of define where the subdivision is going to be collapsing topology and rounding it up, and when it's going to be actually flat. So if I'm going to grab this cube here and we're going to uniquify it, right? And I'm going to move it in here. All right, let me just Shift D this and then uniquify it. All right, and move it in here. And we're going to remove this subdivision for a second, okay? So let's just nuke it. And I'm going to apply this Boolean here, right? So I'm going to apply the Boolean. And I'm going to remove smooth by angle because we don't really need it when we're going to be running a subdivision. And I'm going to press Control 1 for subdivision. You see, what's going to happen is that subdivision is going to collapse all the edges because it's going to smooth out all the edges. So what we need really is we need to define where you want to have sharp edges on that cube, and you can do it with control loops. So for example, if I grab loop in here and moved it all the way to this spot, right? You see now we're starting to get corners defined by these edges, and they're called control loops, okay? Control edges. So you need these control loops to define how you want to run bevels on your mesh. Make sense? You see now that corner is actually very similar to this corner. And if I'm going to apply this, right? So I'm going to go here and apply this. You'll see that the geometry, except for the subdivision here, is going to be quite similar. So the corner here is going to be quite similar, right? To to what we have in here. See what I mean? It's a little bit more untidy though. So if I wanted to run this properly, right? So let's grab a cube and move it in here. I would want to run bevel on all these edges at the same time. So let's just run a cut here, and we're going to apply the cut, right? Remove this smooth by angle, and I'm going to now run a bevel on it. So Q and run a bevel on it, and press Z so I can see this. Scroll to 3 segments, press P to flex them, right? I can flex them now. Press A to change the width of it, and apply it. And now, if I'm going to apply this bevel, right? And again, remove this smooth by angle, you'll see we're gonna get this kind of a situation, which is similar to this one, but slightly different. These bevels are a little bit different, right? Than these bevels. You see that? The arrangement is a bit better. This is much better for subdivision modeling. So if I'm gonna run a subd on this mesh, you see, you're gonna see much less collapsing because most of these edges are being held in place by these control loops. So all I need to really do now is connect these two corners to actually fix my problem and stop subdivision modeling, right? This modifier to collapse inwards on this edge. Because look what happens when I'm going to, duplicate it again and apply this, right? You see this corner is gonna collapse. Why? Because it's not being held by this, this loop here, okay? And the stretching you see in here is caused by the fact that these faces, even though, well, they are n-gons, but if I make them, a quad like this, right? So I went ahead here and I ran a quad in here, okay, like this, right? It's not going to really help me much because these quads are massive and these are very, very small. So when you're running subdivision modeling, you not only need quads, but you also need equal size quads, okay, or even size quads to basically mitigate any stretching that subdivision is going to cause. So even if I'm going to run something like this and mirror this to the other side with Mesh Machine, and I'm going to, grab this edge here and run a knife here across like this and press C, and that didn't work. So let's mirror this and combine it, right? So now we got quads on the top here, except for these are still n-gons. But even again, if I ran a quad in here, so if I ran a knife here, so K, right, and run it all the way here and press C and run through, right, this cube, and then run it down here all the way to the back and all the way here, and then I'm going to mirror this. Now I almost have quads everywhere except for this area here, right? So one more time, C and mirror to the other side, and then it didn't work the way I wanted to. There we go. So now we got quads everywhere, right? And watch this. If I'm gonna run subdivision on this, right? Control 2, right? And I'm gonna apply this, you're still gonna have stretching. Less stretching, but you're still gonna have stretching, okay? Because you got areas which are simply uneven in terms of, the size of quads, and you have areas which are much more dense, right? But it's much better, that the initial nonsense that we have, we had in here. So even if I'm going to, mirror this, right, to the other side, you see the difference in between these two, right? This is much cleaner. This is really, really dirty, especially with all these, edges collapsing here due to stretching, okay? And simply, this cube doesn't have, if I go back in time, right, this cube simply doesn't have enough of support to, support and distribute the subdivision across the surface. So this is a long explanation, but basically I hope you're starting to wrap your head around it. Subdivision surface simply requires a bit more planning, actually a lot more planning, which is why when we teach subdivision modeling, we don't really teach subdivision modeling to beginners. So for example, our course, the Hard Surface Accelerator, which teaches you the Boolean and n-gon workflow, but also goes deeper into the tools, the mechanics, the workflow itself, how to understand design for hard surface modeling, how to render, how to create your first render for portfolio, etc. So it gives you a really nice boost at the beginning. So you're just simply focusing on creating cool stuff, not on the technicalities. Whereas the subdivision modeling is very technical, is really abstract, and it's very frustrating if you're just starting with Blender or any other 3D software. So if you're interested in grabbing our Hard Surface Accelerator, which is a brilliant course for beginners, click the link in the video description and check it out. Going back here, let's talk about the speed. You obviously can tell that the speed of creating the same shape in here with subdivision modeling is way longer because we have to run all these, supporting loops. We have to run bevels, we have to connect edges, make sure they're evenly spaced. So, this is gonna take a few seconds, whereas the same example in subd is gonna take a few minutes. So for example, retopologizing a more complex mesh is going to take, 1.5 hours, whereas creating the same mesh using ngon workflow is going to take seconds. So now the question is, why would you even need subdivision modeling if, if it's more difficult and it takes more time and it's a manual labor, right? Well, it depends on what kind of shape or what kind of purpose your mesh is serving, right? So if you want to go for something a bit more organic, let's say, we're going to grab a sphere here, and I'm going to move it in here, and I'm going to rotate it on x-axis. And we're going to, grab maybe this point here, and we're going to delete that. So delete faces. I'm going to mirror it to the other side. And I'm going to, let me just go to local view with this one, right? So let's go to local view. And I'm going to maybe select the bottom here like this, right? And delete that. And let's say that we wanted to create something cool out of this, right? Something a bit more interesting. So maybe cut this like this here, right? And we're going to nuke these, mirror to the other side, and then here in the back, what I would do, for example, is I would move these a little bit higher and in, right? Something like this. So we're creating a little bit more of a, kind of organic shape here, right? And mirror this. And then maybe I wanted to create some kind of an indentation on the top, right? So let's say we wanted to create a hole in here, right? So we're gonna insert this and, delete those faces. And now let's subdivide this, okay? Control 3. So you see, now what we're getting is we're getting a really nice round shape, right? We're getting a really nice round shape. And, subdivision has this interesting sort of a characteristic where you can, for example, let's extrude it down, you'll see that it's going to create much smoother transitions between areas, right? So it feels a bit more organic, and this will be much more difficult to achieve with a non-subdivision mesh because the angles are way more defined, okay? So for example, if I grab a cube here, right? Let me just grab a cube. And I had a bevel here, right, on this cube. And I wanted to cut some shape into this bevel, right? So I wanted to, run, I wanted to run a Boolean through the shape here, like this, okay? And apply it. Even if I apply weighted normals, you'll see that we're still gonna get this shading distortion here and here. Why? Because we're simply cutting a massive quad, and we're converting it into an n-gon, but that's not the problem. The problem is that this area here, after the Boolean is applied, is going to be simply too large to support the curvature, and the polygon's going to bend. You see, polygons, as long as they quads or n-gons, they can bend like this, right? You can bend them. Now, you cannot bend a triangle, right? Triangles are not bendable. So if I'm going to merge these two, right here, at last, I think my merge is not enabled in machine tools. I was installing 5.1 yesterday, but yeah, of course. Let me just enable these. I don't need this nonsense. I need all these. There we go. And let's go back. So now, triangles cannot be bent. Doesn't matter what you do, you cannot bend them, which is one of the reasons why they use in game engines. But n-gons and quads can be bent. So it doesn't really matter whether you're using n-gons and quads, because you technically can use n-gons for sub-mesh if you know what you're doing. But in this case, it doesn't really matter what kind of polygon it is. It's simply too large and it bends. So when the shading changes and the polygon cannot accommodate to the shading change, to the curvature change, it's going to bend. And it's literally what's happening in here, and that's why you got the shading problem. So what you could do is make them smaller by simply running loop cuts on this mesh. And I know I told you that loop cuts are mostly used for sub-D, but not necessarily, because you can simply make these polygons smaller, and you see now the shading is much cleaner. So there are situations when you can use n-gon mesh and you can have perfectly clean shading on curved surfaces, but you need to know what you're doing. However, if you wanted to make something really supple like this, for example, I wouldn't be using regular n-gon workflow. I would be using sub-D workflow because it's much more suited for this kind of a situation, right? So, you know, if I, for example, wanted to extrude it up, you see the transition between these two edges is going to be really nice and smooth. Whereas if the subdivision wasn't in here, so that we wouldn't be running subdivision, we would be running a bevel, right? So I'm going to run a bevel. You see, the transition is going to be still here, but it's going to be very different. Do you see what I mean? It's not as smooth because the topology is simply quite large, and you see we get this faceting. So even with, you know, shade smooth enabled, you get this faceting here because simply the mesh is too large to cleanly accommodate the curvature. Because when I apply subdivision in here, even at level 1, right? Level 1 might be a bit too small. That's a level 2. You see the, you know, the density of this topology is way higher than this, right? But again, this will require planning, and also once you apply subdivision, you cooked, because any change, you know, in topology, any movement will basically ruin the shading. Okay. Now, there are techniques that you can use to go around it, but basically these are the principles. The core differences between subdivision and the regular modeling, so the n-gon and Boolean modeling for hard surface, would be the control, because you would need to use edge loops to control the subdivision and curvature, but you can also use edge loops to control the shading for, you know, for hard surface modeling when you're using Booleans and n-gons, just like I showed you in here, to simply subdivide locally topology and create smaller, you know, smaller quads or smaller n-gons to fix the shading, right? But you wouldn't be able to run subdivision modeling on this cube, because even if I apply everything to this mesh, right, and I'm going to run subdivision, you're going to get a disaster. Do you see what I mean? Because you still have these, you're still going to have this subdivision collapsing in these areas and basically being super dense in here, right? So you can't do that. You need to prepare the mesh for subdivision differently. You have to work with subdivision in mind when you're running subdivision on a mesh, okay? Second difference is going to be speed. I mean, obviously this is much quicker and much faster, and also much more fun. So if you're doing like a concept design or whatever, this is a way better, you know, way of working, because you don't have to worry about topology, you're worrying about design language. Another one is going to be flexibility. Like I showed you, that once you apply subdivision even one level, then you're going to be in that stuck, because you're stuck with it. So now, why would you be applying subdivision, right? Let's go back to this example, and let's say I wanted to, in this area, right, I wanted to create a really small detail. So let's go back in time, back to when this wasn't applied. There you go. And let's say you wanted to create a really small detail here, right? Let's say we wanted to create a circle, right? So if I wanted to create a circle in here, I can do it with hard ups and go to circle, right? And make it smaller and, you know, subdivide it. And then we can connect these edges in here, and I guarantee you this will not work, okay? And this will not work for multiple reasons. One of them is going to be that we are going to have a pole in here, which is more than 4 edges coming out of this vert. I mean, pole can be 3, 5, 6, 7, etc., right? 4 is fine, but more than this is a problem. And this could be creating some pinching here, although the curvature isn't that steep, so maybe it's going to be fine. But this might cause problem here. So this could be actually too small of a detail to accommodate for this curvature. So let's see that, right? Let's run subdivision, and let's run a, you know, higher level of subdivision. And let's go here to matcap and then see if we can actually see distortions in our curvature. You see that clearly we have a distortion here in curvature. And you know, this is not ideal. It's gonna cause problems. It's really not clean. You see that here, this is not clean. You know, it's not terrible. You can see kind of like a minor pinching here and there. Now this could be mitigated with, for example, shrink wrapping or transferring normals. There's a lot of techniques you can use to fix that, but I'm just saying that, you know, to create smaller details, you will need more topology. So if you wanted to create something really tiny, like for example, you wanted to create, you know, the circle somewhere here, not in the middle, but somewhere here in a specific area, you would need to apply at least one level of subdivision, right? And if you do that, right, you baked, because you cannot really change the curvature of this model. Because if you try to do anything right now, right, even a little bit, right, like this, you're going to basically be affecting, you know, the curvature of this whole model. Do you see what I mean? But that's how you work. So you basically create the overall shape, and then you go deeper and deeper by applying subdivision surface to your model, and then you can create deeper and smaller details. And in fact, if you want to learn how to work with subdivision, you can grab our subdivision course, though this course is not for beginners. It's actually for people who know Blender, and it showcases you a very fast and very efficient add-on workflow for subdivision modeling that will teach you how to run subdivision very efficiently, very effectively, and really, really, really fast. And I'll show you how to create this awesome bot from scratch using subdivision surface modeling and a lot of add-ons, including Hardops and box cutter, which is kind of ironic because a lot of people think that these add-ons are just for end-gun modeling, which they couldn't be more wrong. They just simply don't know these add-ons. And if you want to learn the add-ons, Hardops and box cutter, you can grab our other course, the Ultimate Guide to Hardops and Box Cutter 2.0, which is going to cover everything you need to know and more about these add-ons so you can master them. And trust me, these add-ons are amazing. They're going to save you a shit ton of time. We estimate you can work about 8 times faster with these add-ons. All the links are in the video description. By the way, going back, I think they changed the matte cup in 5.1 because this one is really cool. It's a bit more matte, and I really like this one. This one I think is the original one, which is awful. This one is really good. That's a fantastic matte cup. By the way, I digress. So, that's how it works, right? So, the flexibility is a little bit difficult with subdivision modeling, especially that when you're modeling with with booleans and you are working with live booleans, which means you can still adjust stuff, move stuff, mirror stuff. You can do all that stuff here, and you're not really bound to this shape. You can manipulate with this cutter, right? You can do all kinds of stuff, and you're gonna be fine. Whereas this would be much more difficult to do when you're working with subdivision modeling because you kind of bake to a specific shape, right? Now, surface behavior obviously is very different. Here you control shading using loops and flow of topology. And flow of topology basically means the topology flows with the shading. So for example, here there's a loop that flows around this cutout, which support the flow of topology, which is why you're seeing really clean shading around this shape. If it wasn't going along with this cutout, you would be seeing issues and problems, especially when you're gonna have poles, somewhere here on, in this area. If I'm gonna add an edge in here like this, even though, right, I'm gonna have quads here, and I'm gonna prove it to you. Watch this. I'm gonna create a quad in here like this, right? This here on the bottom doesn't matter, but what matters is this here. Okay, so this is gonna be quad, right? See, that's a quad, right? And this one doesn't matter. So watch this. See what I mean? And I'm gonna enable subdivision, and you see that pinching here, right? I got all quads. They're all quads, but look at this. And I didn't move any of them, right? I didn't move any vert. I just added more topology. That's the problem. So controlling shading in subdivision is on a different level, and you really need to understand Blender on a pretty good pretty good level in order to even start modeling with subdivision without getting frustrated, okay? Which is exactly why we don't teach it to beginners, because I think it's retarded. Now, lastly, you're gonna have, surface behavior, which is gonna be different. So this is gonna create, the subdivision will create very smooth and very organic shapes, whereas the traditional hard surface modeling is gonna create more of like a mechanical feel to your model. Is going to be way more angular, and the surfaces, the curvature is going to be a bit more mathematical and precise, whereas sub D is way more organic and kind of a smooth flowing, right? Now you can obviously combine both techniques together in one model, so some parts can be sub D, some parts can be n-gon Boolean workflow based, but at the end it depends what's your goal, like why you're creating this model. Because if you're creating a model, for example, for VFX, you will need quads, most likely, right? If you're creating this for, like a character for animations, or you're gonna be bending the mesh, or it's gonna be exploding the mesh in the game, for example, a ship that breaks apart, you're probably gonna need subdivision modeling. If you're gonna be creating some complex textures and non-procedural textures that may stretch during UVing and unwrapping, you're probably gonna need subdivision modeling. So there are a lot of instances where you will need subdivision modeling, but you may not need it all the time or in all situations, right? In addition, what you could do is simply create a model using, let's say, plasticity, and you can import these models to Blender, and you could simply retopologize them, which is, by the way, what I'm gonna be showing you in the new course for plasticity. it's gonna be a sci-fi gun course, and you know, I'm just gonna show it to you. So let's just go back here, and this is the gun we're gonna be modeling in plasticity, bringing it to Blender, and then we're gonna be retopologizing this piece, you know, in Blender using Blender tools. And you could do this as well, and then you could simply reuse this mesh, you know, wherever, however you want, because the mesh from plasticity is usable for texturing, but you know, you can't really do much more with it. You could actually, you know, still retopologize it a bit better using the plasticity bridge add-on, right, which is, you know, which is this one. But you need to be connected to plasticity and do it during the import. But yeah, you could create better mesh, but you know, it's never gonna be really as clean, obviously, as this, where all the loops are being run properly. You have all these, you know, loops around specific areas, etc., which is how, you know, how retopology should be run. And if you wanted to do it properly, that's how you need to do. But that takes a lot of time. You know, just this grip takes about 1.5 hours to do. Okay, it takes a lot of time and patience to do it, right? So if you don't need to do this, right, don't do it, because you know, you can easily run smooth edges and smooth surfaces in different software, like for example plasticity. Okay, that's why I don't agree with the term clean topology, because for me clean topology is clean shading. Topology itself is just a tool, and you need to know what you're using it for. And you know, when you know your purpose, then you will know which tool you should be using and why. Now, other issues with subdivision modeling obviously going to be problem solving, because if you have a problem and you want to change something, and let's say I'm going to apply one level of subdivision and I wanted to change something on this mesh, it's going to be way more difficult than doing it in here, because I'm dealing with way less topology, and I don't have similar issues as I have in here. Okay. So, you know, definitely this Boolean workflow is much quicker, much more intuitive, much more user-friendly, much more beginner-friendly, and much more artist-friendly. There's no planning really involved other than creating better blockouts, whereas with subdivision modeling, you really need to know how to plan ahead and how to, you know, it's much more intellectual, mathematical, because you need to count the verts, you need to count the loops, you need to make sure that everything converges correctly. All the edges from all the details, you know, are properly connected throughout the mesh. There are no rogue edge loops running across the mesh, increasing topology count for no good reason. There's a lot of stuff you need to pay attention to, you know, edge flow, for example, or change of the edge flow. Let's say you have multiple details on the mesh and you need to change edge flow between the details. And on top of this, you need to control the loops and shading. It's a lot to take on board if you're starting with modeling. Even if you're intermediate, it's still going to be a bit of a struggle. So I would suggest you start with Ngon Boolean workflow, because it's a lot of fun. It's going to teach you a lot about Blender, shading, and you need to understand shading before you're going to get into Subd, trust me, okay? Because Subd shading is on a different level, it's way more complicated, right? Now also detailing is going to be much more simple in here, because you know, I can create very you know, details here very easily, right? Just you know, running my my box cutter. So you know, details can be created very quickly and very easily just using booleans, and you can have a lot of fun, you know, creating them. And it's super intuitive to do that. And if you want to, you know, undo them, you simply delete the booleans and you're done. Do you see what I mean? So it's so much more on the creative side, in my opinion, whereas subdivision modeling is more an analytical side, okay? More nerdy way of modeling, if you will. And lastly, the time, you know, Subd, like I showed you, takes a lot of time, and this one is much quicker. So, you know, again, pick your battles, and if you don't really need to model in Subd, don't do it, because you're going to be banging your head against, you know, a wall, and then you're going to find out it wasn't really necessary. So, you know, there is no point of doing that, okay? So again, if you want to learn the basics of Blender and the workflow and the tools and the menus, and you're still kind of confused about how to use them, whether you're an absolute beginner or intermediate, grab our Hard Surface Accelerator course. It was made for people like you. In this course, we are showing you not just the tools, not just the menus, not just the workflow, but also talking about principles of design, how to design better stuff in Blender. And that's the focus of the course, to help you become better at modeling, have more fun, and bring your, you know, ideas to life without any frustration and getting stuck. In addition, we're going to show you how to texture your models, how to render them, how to create your first, you know, portfolio piece that's going to attract potential clients. And if you want to go deeper and learn subdivision modeling, make sure you know the add-on workflow, for which we also have a course, like I told you, the ultimate guide to hard ops and box cutter 2.0. but then grab the subdivision course, which is fantastic. Now in this course, I'm using probably about 10 add-ons. Some of them are free, some of them are paid. I'm using Hardops, Boxcutter, Mesh Machine, Machine Tools, Keyblerator. I'm using a lot of add-ons, okay? Edgeflow, there's a reprimitive, there's a lot of add-ons being used. All the add-ons I think are necessary for very fast workflow. The emphasis is on speed because SubD is really slow, right? Really slow. Since AI is so miles away from, retopologizing properly, you're gonna have to do it manually. Tools like, for example, QuadroMesher will not help you unless you are sculpting, because simply they're not good enough yet, and they will not be able to place loops in specific places where you're supposed to be placing. So manual retopology gonna be a must. So you might just as well model from scratch using, if you want to do it in Blender, either sculpting and retopologizing or modeling from scratch using Subdivision. And that course, the Subdivision course, show you exactly this, how to model from scratch using Subdivision modeling and add-ons. So the links are in the video description. That's it for the video. Thanks for watching, and I'll see you in the next one.